All right, let's get started. Again, welcome to anyone who has joined us today. I'm Samantha Link, and I'll be moderating today's webinar on rapid UT gridding for acid equipment. As we go through the presentation, all attendees will be muted, but please be sure to send us questions to the Q&A feature located at the bottom of your Zoom screen. I'd like to go ahead and introduce our presenter today, Chris Wolf. Chris is an oil and gas industry manager at Gecko Robotics and has been in the oil and gas industry for the past couple years. Chris has become a huge proponent in helping refineries understand robotic capabilities in the NDT space, as well as data utilization for rapid ultrasonic gridding inspections. And with Chris today, we'll also be hearing from principals at Acid Piping Technology, Ed and Alex, and their experience with equipment for acid plants. Let's all welcome Chris. Looks like Chris might just be having some trouble unmuting a little bit.
Okay, can we all hear me now?
Gotcha, good to go.
Okay, sorry about that. Yeah, good afternoon to most of you, perhaps morning to some of you if you're on the West Coast. Thanks all for attending today. As Sam with the warm welcome, I appreciate that. I'm also joined with Alex Knoll and Ed Knoll with Acid Piping Technologies. I know they invited some of their contacts and clients to the call here today, so I will, Alex, Ed, if you want to give a quick intro, I'd appreciate that. I think perhaps are you guys muted?
Chris?
Hey, we can hear you now.
Okay, good. Sorry. Anyway, I'm Ed Knoll with Acid Piping Technology. We're in St. Louis, Missouri. One of the things that we've been quite interested in is the robot's ability to inspect MONDI piping. For those of you not familiar with MONDI piping, it's the most popular material for piping sulfuric acid. It's a centrifugal cast alloy of ductile iron with unique chemistry for corrosion resistance in strong sulfuric acid at elevated temperature. It's designed to have a long life, 30 years for most of the larger sizes. However, it is important to monitor the pipe to ensure that you don't have any surprises. There are things that can cause an issue, such as some eddy currents developing, some unexpected plant shutdowns that leave stagnant acid in the pipe for a long time, or even extended mothballing of a plant, maybe not done properly. So one should monitor their pipe to spot possibly corrosion trends. And we're most impressed with the ability of the robots to do a much more complete examination, UT being the most popular way to examine sulfuric acid pipe, especially in service. So we're impressed that this offers an opportunity to do it on a broader scale, much more efficiently than handheld. And I think otherwise, Chris, you've already tested it and proven it on MONDI, so I'll let you take it from there.
Yeah, I appreciate that, Ed. Yeah, to give everyone some background, this conversation, a lot of this conversation started when we were just investigating if we could do rapid ultrasonic gridding on MONDI. It turns out RUG is a great application for MONDI piping. And then based on some of the work that we've done that RUG has been used on within at refineries, downstream oil and gas, midstream as well. It sounds like there's a lot of translation to be able to use rapid ultrasonic gridding at acid, on acid equipment in general, acid plants, or on the acid units within refineries. So what I'll go over today is the current state of inspections for acid equipment. I'll go into what is rapid ultrasonic gridding and the future of inspections for acid equipment. I hope to use up about half our time here on that, and then really the rest for Q&A. I welcome y'all's questions and insight to acid equipment, and just as much as I hope to show you some things here, also learn from you guys. So within acid plants, there are a number of codes codes and guidelines that you can follow and programs that you're running. There's NACE, there's API guidelines, there's RBI programs you might have in place, and there's also a lot of sulfuric plants in particular have a 2-year cycle between when their catalyst is cycled or when the boilers are brought down for inspection and maintenance. My understanding with sulfuric plants is a lot of the goal there is to go the full 2 years without having an unplanned shutdown. But between the different codes and between just general unplanned events and circumstances, it's not always easy to do that. Combined with just the nature of corrosion from acid and erosion from acid, it's tough to run a good program. So, I mean, there's general thinning, there's localized corrosion in your lines, on your vessels. There's even where acid might be leaking, where it collects might not always be by the source of the leak. Corrosion can be tough to predict and find, even if you have a thick wall, right where you happen to be testing, there could be a deep pocket of localized corrosion not 12 inches away. Then especially on the piping, like MONDI piping, if say a flange is installed improperly or the wrong size gasket is used, there could be pockets of erosion and eddy currents collecting within half an inch to 2 inches of that flange. So the combination of these things can cause rapid deterioration of the assets and a loss of life expectancy. And as Ed mentioned, if there are shutdowns, I mean, that can accelerate corrosion too. So it makes the life of inspectors and reliability managers and engineers and maintenance difficult to deal with this stuff, whether you're at the acid plants or working on acid equipment within refineries. For sure, I can understand that. I'm sure we all know the costs of failure. First and foremost being personnel safety and plant safety. Then of course there's environmental hazards posed by leaks and spills. There's the loss of production and the dollars associated with that, and then also the downstream loss of production to people downstream of your sites and what you're producing. But the problems, as with most inspection, the classic problem is it's usually cost prohibitive to get a high quality and a high quantity of data. Scaffolding assets using advanced technologies can be very costly. So what I'm presenting today is a method called RUG, or rapid ultrasonic gridding. And there's a couple different methods to do this, but the idea is that instead of laying down a manual UT grid with a hand scanner, you can use robotic technologies to do this sort of scanning to collect many UT readings on a grid, perhaps hundreds of thousands to millions of UT readings, depending on the asset that's being inspected. This can be done quickly, it can be done safely, it can be repeated over time, and it can be mapped so that you know exactly where these readings were taken. I'll play a quick video here. just showing applications of rug across across some of the different asset types that is. So y'all can get an idea of how it works and how it drives and maneuvers. So you can get an idea. There's a few different use cases for rug. Both its speed is a big one. Its maneuverability into difficult to access spaces, overhead equipment, towers, stacks. It can get into a lot of spaces, say without scaffolding and ropes. It can get you a very detailed grid. Inspections can be repeated. You can get anywhere from 1 reading per square inch up to about 80, depending on the asset you're doing, you're inspecting, and the configuration on the crawler. So rug is an inspection type. I mean, you can do manual UT gridding. You can do automated ultrasonic gridding. You can, of course, do spot UT. But as you're collecting as you're collecting data and choosing your tool for inspection, right, it's always a combination of data quality, speed, and cost, right? Especially if you are running an RBI program, the question is always how do you get a high amount of data quality, make a highly confident evaluation within a speed and a price range that's comfortable for you.
So Chris, there's a question here that's asking, which fixed equipment assets are the best fit for rug?
So for fixed equipment, rug works best on assets like pressure vessels, like cylindrical tanks, like both horizontal or vertical, stacks and towers, any sort of piping. Anywhere there's clean metal or relatively clean metal, dust and paint and water, it doesn't have to be necessarily clean. What I mean is free of obstacles that will get in the robot's way. Usually ferrous, so uninsulated if we're inspecting from the outside, or any sort of ferrous metal to get robotic adhesion. We can do some sorts of unferrous metal, like if we're going to do a tank floor, we could do, say, a stainless steel sulfuric acid tank floor, because we don't need robotic adhesion. But yeah, in just a couple slides here, I'll share some of the other asset types that are great for rug.
And then one other question, and I think this is more specific to the robot, but how does the tool know where it is on the vessel or pipe?
Yeah, that's a great question. So the robot has an encoder on it that's taking coordinates as it plants or as it collects each UT reading. So it's not a continuous scan. It's collecting hundreds of thousands to millions of A scans as it crawls down the asset. The operators are taking notes of start point and end point with their digital controls, and then all this data with its coordinates are being mapped in the resulting corrosion map, which will look something like this. So when reports are turned over back to you as the customer, we'll take those millions of UT readings and represent them on the grid. Of course, we don't want to give you billions of UT readings to sort through. So it's going to be, we're going to represent the lowest UT reading found within any pixel here on the grid. So this is just like a small section of a tank floor, really like a sketch plate, right in that critical zone. We can get within about ½ an inch of the critical zone between the floor and the shell. Our outer transducer will really sit on the toe of the weld there. So each of these boxes here has X and Y coordinates relative to the 0 point or the hash marks that we use from the inspection. And so then going out to actually find these readings back in the field, or if you go back in the tank, you can count boxes, whether they're 3-inch boxes, 6-inch, 12-inch, what have you. But we'll actually supply a number of different reports and tools to make this easy for you. These are examples of a few different types of reports that we'll give, whether it's piping or vessels or spheres. We'll deliver the Excel report that I was just showing, these PDF inspection reports, and also the online interactive version known as the portal, which I can show towards the end here. So I'm just looking at 2 questions here. Will it work for tanks that are lined with Teflon or rubber? As long as we can get magnetic adhesion to the to one side of the tank. So say if we're just doing the shell from the outside, we can absolutely crawl a carbon steel shell from the outside to take readings to look for, say, any corrosion going on underneath that liner. For tank floors, I mean, it depends on the thickness and the type of the liner, whether or not we can inspect through it. That's always a case-by-case basis.
Great. And then this one question here, how close can the crawler get to the back of the MONDI flange to obtain a reading? A lot of MONDI failures occur just behind the flange due to the threaded flange. Right,
yeah. Ed and Alex have been really helpful in helping us understand how the issues do collect around the flanges. The answer is we can get within about ½ an inch of the flange. That is to the flange itself, not necessarily the back of the flange. We understand that eddy currents right by those flanges may cause corrosion, like right around the flanges. Our robots are gonna get within about ½ an inch, which, still not a perfect solution, admittedly, but what we are hopeful for is that, taking a few hundred to a few thousand readings per spool of MONDI is going to give you a lot more information to make your decisions with than just, say like 8 or 12 measurements per segment. Then the minimum diameter piping the robot can attach to and still take effective UTs. Thanks for that question, Patrick. It's about 6 inches, 6 inches in outer diameter, or with MONDI, right? That's about 4 inches in inner diameter. So really just about all ranges of MONDI piping. So I kind of alluded to this, and this is pretty much where the discussion is going, but ferromagnetic substrate, except for tank floors, temperatures under about 250 degrees. We use water as a couplant, and for assets as hot as 250 degrees, but we're still using water and actually pumping that through the system to keep all the components cool. But 250 Fahrenheit is just about our upper limit. If we need to go hotter, around 300, we've experimented with using some high heat couplants, and it's something we might be able to do if the equipment is just outside of that 250 range. And then, yes, weld seams build up in obstacles. We can generally crawl over about ½ inch obstacles. But yeah, when we get to the flanges on MONDI sections, we're going to need to manually lift the robot over those using a JLG or even perhaps rope access. So to that question in the beginning about assets that are good for MONDI, it's going to be piping as small as 4-inch ID and or 6-inch OD. That's MONDI or carbon steel. It's going to be tank shells, floors, and roofs. Again, those floors can be carbon steel. They can be sometimes lined. Coated floors are usually no problem for us as long as it's not fiberglass. Boilers, heaters, and tubes. I'll play a quick video here. We can generally get on tubes as about small as 1 inch or 1 1/4 inches. Here's a quick video showing a robot crawling a tube wall and making a transition from the lower slope to the vertical. So you can see we're sitting a transducer on the right, left, and center of each tube. And as the robot inspects a tube wall, we'll just slide it down every tube to be able to collect readings at every elevation. We can do that, say, every 3 inches or 6 inches or whatever is needed. It's also going to be great for doing on-stream inspections of vessels and pressure equipment, drums, stacks, towers. Especially in these times, on-streams have been a big request so that teams can understand what are the vessels most in need of inspection right now and what can wait for inspection next year or even 2022.
So a couple questions in here, Chris. So what are the temperature limitations of the crawler for in-service inspections?
So, Sam, can you repeat the question again? Sorry.
Sure. The temperature limitations for in-service inspections.
Right. Generally about 250 degrees Fahrenheit surface temperature of what the robot's actually going to be sitting on. That's our upper limit.
Great. And then the maximum thickness of paint or coating thickness that can be discriminated?
So usually we can inspect through paint up to about 100 mils. Certain 50 to 100 mils we're pretty comfortable in that. Anything much thicker than that, we're going to have to, it's going to be a case-by-case basis. But paint and coatings, as long as it's well bonded, not usually an issue for us. We can also, because we're using, the transducers are immersion-based straight beam UT transducers or bubblers. That water cone helps them get over external scale and paint chips and just general debris on the assets themselves. So yeah, anything in the 50 to 100 mils not such a big deal for us, and it generally our transducers enable us to get good coatings. Get good readings through those kinds of coatings and obstacles, anyways.
And then one person wants to know if we've had success with tubes greater than 1 1/4 inch that are not finned.
Yes. So perhaps this question is talking about say heater tubes. So I wish I had a picture of it handy, but yeah, to give you an idea, it was like a hot oil burner with some horizontal tubes that were about 5 inches in diameter, and they're spaced maybe like 6 inches apart, and they weren't finned. The answer is yeah. We ended up sitting the robot on 2 tubes and sitting 3 transducers on each tube, and just a wider configuration of the robot to take readings very similar to this tube wall here, but just different spacing. So usually for each inspection, what we'll do during the quoting process is just ask about configuration of the asset and what your data collection needs are, and make sure that we can get a configuration that's going to work for you, or that if the configuration doesn't work. You know, sometimes it's not always a fit. You know, like anything, you know, rug has a lot of pros, but it's not a perfect solution for everything, by no means. So on the MONDI, this is an example of, this was a 5-foot test section sent to our lab. We ran the robot from end to end, and we're able to map several hundred readings on this section. You can see on the right here is the resulting corrosion map from this test section. You can see there's very evidently general thickness from one end of the line to the other, based on the flow of the line. So all in, I mean, rug is a great application for measuring both general thinning as well as localized thinning, localized corrosion, that is. Magnetic adhesion on the MONDI is still strong. There was a bit more signal scatter, you know, being a cast pipe, right? It is tougher to get UT readings, but because we're taking so many UT readings on the pipe, we're still able to map this resulting corrosion map here. So we end up throwing out closer to 30 to 40% of our readings, whereas during a typical inspection on, say, carbon steel, we're only throwing out 10 to 20, but we're still able to get plenty of data.
So one question that somebody has is, why is rug better for MONDI piping, and overall, how does it work?
Right, so the way I understand that MONDI is currently being inspected is mostly with manual UT readings, whether that's just spot checks, you know, a couple around the flange and a couple on the spool itself. That can be helpful for understanding as far as spot checks go, for sure, but you know, sending humans up around this stuff can be dangerous in general. And then also just due to the nature of how the corrosion and erosion works. I mean, even if you happen to land spot readings on a couple good areas, there could be significant corrosion and loss of material just a few inches away. So rug is great for getting that full picture. It can also be repeated over time, and it can quickly, safely, accurately get you a corrosion rate that you can monitor.
And then how do you show loss of signal in the graph?
That's a great question. So some of those white spots that you see on the graph, those are areas where we weren't able to map any readings. So maybe in those areas there's too much signal scatter, or something was messing up our ability to collect readings. So we'll actually just show blank spots in those areas rather than reporting data we're not 100% confident about. So that's one method, but to more broadly answer that question, the data is processed in a 3-step way. As the operators are running the inspection in the field, they'll watch the UT scans come in on a computer, the base station that the robot's hooked up to, and make sure that the reading, they'll see the A scans rolling in and make sure that we're getting strong signal. If signal starts to weaken on the base station, they'll back the robot up and run that section again. And it could mean a few things. It could mean maybe there's lots of pits in that area. Maybe there's lots of external scale. Maybe there's actually something going on with the robot and something needs to be reset. But that's the first step. Second is all of the data, all these A scans are uploaded and analyzed with a few different algorithms to look at the height of the peaks, the frequency between the peaks, to say, are these thickness readings? Is this pitting? Is this lamination? We'll have our computers go through the brunt of all that information to make the first determinations. And then the third step is for our human data team to actually look at the readings that are flagged as potential pits or potential laminations. They'll look at the B scans, they'll look at the combination of the A scans, they'll look at what the different algorithms are telling them to make confident decisions on what the robot is really seeing there. So I can I can show a couple case studies here. It looks like another question just came in. How long would it take to scan a 10-foot spool? The short answer is very quick. The robot moves at about a foot per second. So I mean, theoretically, we could, once the robot is on a 10-foot spool, we could, just run it down and back, not much longer than a couple minutes. But just on this example, this was a 6-inch line right here. I think we ran 5 runs all around it to make sure that we're getting a high volume of data. And so, yeah, I mean, running 5 runs all the way around it just adds a little bit of time, but still just a few minutes per spool. Seeing another question, do team members have API certifications, inspections like 653, 510, 570? Yes, we do have those in-house. All of our inspectors are at least level 2 certified, and we do have API inspectors on the team as well. So I can run through a couple case studies showing Gecko on various kinds of acid equipment and equipment in general. If it's not specifically acid equipment here, it's to give you an idea of what we can do on acid equipment. This was a HF Alky unit, an acid settler, and 2 rise reactors that we inspected. We got full coverage of the acid settler and the rise reactors in about 2 shifts, using without ropes or without scaffold. This is actually a video here, and you have to look closely, and I'll point it out of where the robot is. You can see it being deployed from one of these platforms about halfway up the tower there. Sorry for the noise, it's a little annoying. So you can see it's working its way down that tower from the platform. It'll crawl under those pipes there. It'll crawl between the tower and the platform itself. So we ended up mapping this asset in just about 2 days. As far as piping goes, this is a 6-inch water line. It's actually a sour water line, 6 inches outside diameter, that is. We did the bottom half of it, about 751 linear feet, and it took us about 3 12-hour shifts. So we collected 650,000 UT readings over that section, which averaged to about 8 per square inch. So that helped them target areas for further repair and evaluation. Now, clearly this is not a flange pipe. So for MONDI, getting up and over each flange would add some time for us. But still, the data density would be about the same. Tank floors, I'm thinking sulfuric acid tank floors, water tanks, really anything you got. Gecko is a great application for doing fully quantified thickness mapping of tank floors. And we can even lay it out with your plate diagrams. So this will show an example of, this is actually one of our older generation robots, but how we can inspect in the critical zone. Again, you'll see that UT transducer is sitting right on the toe of the weld there in the critical zone. So it works well for annular rings, if you happen to have those in your tanks. Also, it can get under heating coils if those are present. Also, this technology can be deployed without confined space entry in above ground storage tanks. So if it's important to run inspections without getting someone in there, that's in our wheelhouse. Looks like a question just came in. Time estimate for scanning a 30-foot diameter tank. Yeah, I mean, we could do a 30-foot diameter tank in less than 1 12-hour shift. what you're seeing here is this is a 40-foot tank floor we did, and also one 12-hour shift. And this is actually with our older generation robot called the Toka 4. We collected over 2 million A scans on that 40-foot floor within that 1 hour shift, or sorry, one 12-hour shift. Sorry, Rod, I didn't mean to come across like that. I appreciate your question, but yeah, absolutely, we can knock out a 30-foot tank floor in just about a day. We'll usually also allow a day for safety training and just general setup, especially if it's a new client. We haven't been to your site before, we haven't worked with your company before. Generally, it's about half a day to a full day, depending on how long safety training is and stuff like that. So does an external 100% UT count as an internal? I don't think so. I think it really depends on what code you're looking at, what guidance you're using, and your own program that you've designed on site. No, I don't think that 100% external definitely replaces an internal, but based on the guidelines, it may allow you to push out that internal inspection. So I've shown you a lot of assets that are like kind of clean metal and good for the robot, but we certainly understand that assets are also, there's a lot of congestion around them, sometimes steam coils and just other things tightly woven around them, right? Like refineries and acid plants and just plants in general were not made to be ergonomically inspected. They're made to be operationally efficient in producing stuff, right? So this is an Alky unit vessel that had steam coil on it. The client was primarily looking for localized corrosion and pitting on the top half of this horizontal drum, or vessel rather. And so we were able to work around the steam coil. You can kind of see some of these white areas on the map. We can maneuver the robot to a fair degree and get as much coverage as we can. We can also fill in with manual UTs if our operators can get within arm's reach. But I just wanted to give an example of what it looks like when an asset has a lot of stuff in and around it or going on around it. Still, we averaged about 5 UT readings per asset here to help them identify exactly what's going on with this unit and their other unit. So something I mentioned in the beginning of the call, it sounds like a lot of sulfuric acid sites are on this 2-year cycle, in between a few things when they're having to cycle their catalyst and also to do boiler maintenance. And I thought this was a good slide to kind of end on here. Rug technology, at least for Gecko's foray into rug, started with doing boiler inspections, and this video shows the progression of that. We're now, when we inspect boilers, when rug is used on boilers, we can do the 2D thickness mapping of say a boiler wall, and we can give you a pretty interactive view as to what's going on. So any one of these pixels of the boiler is going to show the coordinates of where that thickness reading was taken, what that thickness reading is, and pictures of what the robot is seeing at that point. There's also tools built in to quickly identify any readings below a certain threshold. We call that the fitness for service slider. Also, if you're mapping inspections over time, we can show how those inspections compare to each other and where spots of increasing corrosion are. Then we can do 3D mapping. This can be useful for a number of things, and generally looking at the condition of your asset, perhaps making a capital budget case, and you screenshot this and throw it in your report. Or just sharing this with your maintenance team or any of your other teams. to give a quick idea of what's going on. All you need to do is pop in their email and you can share access with them. But yeah, boilers, when tubes are parallel, that is a great application for Gecko to be able to get in there. Non-parallel tubes, not so much. But at this time, I would like to thank you guys again for watching so far, and open up the floor for any questions.
Thanks, Chris. This has all been really great. And thanks to everyone who also submitted questions into the Q&A. So at this time, if you want to continue to send in some questions, we have a few extra minutes that Chris can probably answer those. And then if not, I think, Chris, maybe your next slide also has your contact info if you want to reach out to Chris directly. But we'll also be sending out a recording to this webinar to everyone who has registered. So if you had a colleague that didn't get a chance to make it, we'll still be able to send this out to them. And then we'll also make sure that everyone who's attended today also gets a copy of it so that you can share it with your colleagues.
Awesome.
So Chris, looks like somebody's asking about a cost comparison to rope access.
Yeah. So it's not always rug versus rope access. I just had 2 jobs recently where we actually worked with the rope access team to get the inspection done. It was the type of situation where the robot needed to be lifted into place because there was no other option. So sometimes we can work in conjunction with them. Cost is always a case-by-case basis, at least in the case of Gecko, right? There's other applications, there's other tools for rug like AUT, but for Gecko, we quote on the size of the asset, like the square footage. So all it takes is dimensions, and I can help put a quote together per project, and hopefully that can demonstrate where our cost is versus doing traditional inspections. What I will say is that if you are interested in scoping out any assets, feel free to take my info here, and we can have a conversation. But this program is designed to be, or Gecko does have programs available that are designed to be cost effective, especially for sulfuric acid sites. It looks like Aaron said, generally the robots will need something ferromagnetic to crawl on, to stick to. But in the case of stainless steel tank floors, we can also generally do those. Might need to switch out the transducers based on the type of stainless steel. But yeah, mostly ferromagnetic assets are in our ballpark. I know we did talk about insulation a little bit at the beginning of the call. We're not going to be able to inspect through insulation, but if you do happen to have the assets offline and we can get inside them, Gecko is a fantastic application for inspecting on the other side of the insulation and looking for corrosion under insulation. We've also done that with say fireproofing, getting on the other side of fireproofing as opposed to removing it at all and then inspecting it